Integration by parts. What is integration by parts? Integration by parts is a method for integrating products of algebraic and non-algebraic functions. For example, the integral of x squared cosine of x dx. X squared is our algebraic function and cosine of x dx is our non-algebraic function. Another example of this is the integral of x times e to the 2x dx. X is our algebraic function and e to the 2x dx is our non-algebraic function. How to. The formula for integrating by parts is the integral of u dv equals uv minus the integral of v du. Step 1. Determine u and dv. Choose u so that du is a function simpler than u. Choose dv to be the scariest or the most difficult portion of the integral.
When choosing u, you want to make sure to use Liate to find u. L stands for logarithmic, such as log of x or ln of x. I stands for the inverse or arctangent of x. A stands for algebraic, such as x or x cubed. T stands for trigonometric, such as cosine of x or sine of x. And E stands for exponential, such as e to the 2x or 10 to the x. Our first example is the integral of x sine of x dx. And using Liate, we can let u equal x, because that is our algebraic function, and we'll let dv equal sine of x dx, because that's our trigonometric function. Step 2. Once you've determined u and dv, use calculus to find du and v. So back to our example, we have u equals x and dv equals sine of x dx, but we need to find du and v. To do that, to find u, we'd take the derivative to get du equals dx. And to find v, we'd integrate dv, or sine of x dx, to get negative cosine of x. Step 3. Plug in the values for u, v, du, and dv into the formula and solve from there. So here we have u times v, or x times negative cosine of x, minus the integral of v du, or negative cosine of x times dx. And from there we solve to get negative x cosine of x plus the sine of x plus c. Always forget to add the c at the end whenever you integrate.
Another example of integration by parts is the ln of x dx. This is a common trigonometric function that it is good to know how to take the integral of. So we have u equals the ln of x and dv equals dx. du equals dx over x and v equals x. So back to our formula, the integral of u dv equals uv minus the integral of v du. So plugging in all of our functions, we have u times v, or x times ln of x, minus v, the integral of v du, or x times dx over x. Here, our x's simply cancel, and we have the integral of dx, which is just x. So our integral of the ln of x equals x times the ln of x minus x plus c. Never forget to add the plus c at the end of an integral.